Welcome to this tutorial on profiling Kotlin code, where we'll explore performance analysis and bottleneck detection. Profiling is an essential skill for any developer who wants to write efficient, high-performing applications. Throughout this video, you'll learn how to identify performance issues in your Kotlin code and understand where your application is spending its time and resources. Profiling is the process of measuring program execution to identify performance bottlenecks and resource usage patterns. Think of it as taking an X-ray of your application while it runs. Profiling measures execution time of methods and code blocks, showing you exactly where your program spends the most time. It tracks memory allocation and garbage collection, helping you understand how your application uses memory. Most importantly, profiling identifies hotspots, which are the specific areas in your code where optimization is needed the most. There are 4 main types of profiling you should know about. CPU profiling measures how much CPU time is spent in each function or method to identify computational bottlenecks. Memory profiling tracks memory allocation, retention, and garbage collection to detect memory leaks and inefficiencies. Allocation profiling monitors object creation patterns to identify excessive allocations that impact performance. Finally, thread profiling analyzes thread behavior, synchronization, and concurrency issues in multi-threaded applications. Each type serves a different purpose and helps you understand different aspects of your application's performance. Several powerful tools are available for profiling Kotlin applications. IntelliJ Profiler is a built-in profiler with CPU and memory analysis capabilities. Android Profiler is a comprehensive profiling suite available in Android Studio. JProfiler is an advanced commercial JVM profiling tool with extensive features. YourKit is another professional Java and Kotlin profiler used by many enterprises. VisualVM is a free visual JVM monitoring tool that's great for getting started. Finally, JMH, or Java Micro-Benchmarking Harness, is a framework specifically designed for micro-benchmarking JVM code. Each tool has its strengths, and choosing the right one depends on your specific needs. Using the IntelliJ Profiler is straightforward and follows a simple 4-step process. First, click Run with Profiler from the Run menu in IntelliJ IDEA. Second, your application runs normally while the profiler collects performance data in the background. Third, once execution completes, you can view flame graphs, call trees, and method statistics that show you detailed performance information. Fourth, analyze this data to identify hotspots by focusing on methods consuming the most CPU time. These are the areas where optimization will have the biggest impact on your application's performance. For quick and simple profiling, Kotlin provides the measureTimeMillis function, which is a fast way to measure execution time of specific code blocks. You import it from kotlin.system.measureTimeMillis. Then you wrap the code you want to profile inside the measureTimeMillis block. The function returns the execution time in milliseconds, which you can print or log. This approach is perfect when you want to quickly check how long a specific operation takes without setting up a full profiling session. Let's look at the most common performance bottlenecks you'll encounter. Inefficient loops include nested loops with high iteration counts or unnecessary operations performed inside loops. Excessive allocations happen when you create too many temporary objects, which triggers frequent garbage collection and slows down your application. Blocking operations occur when you perform synchronous input-output operations or database queries on the main thread, freezing your application. Poor data structures result from using inappropriate data structures that lead to inefficient lookups or insertions. Recognizing these patterns will help you write better code from the start. Understanding profiler output is crucial for effective optimization. Flame graphs visualize call stacks and help you identify which methods consume the most time at a glance. The wider a section in the flame graph, the more time was spent there. Call trees show hierarchical method calls with the time spent in each method, helping you trace execution paths. When analyzing performance, you need to distinguish between self-time and total time. Self-time is the time spent in the method itself, while total time includes all nested method calls. This distinction is important because a method might have high total time but low self-time, meaning the actual bottleneck is in the methods it calls. Memory profiling uses several powerful techniques. Heap dumps capture memory snapshots that let you analyze object allocation and retention patterns, showing you what objects exist in memory and why. Allocation tracking monitors where objects are created, helping you find excessive allocation hotspots in your code. Garbage collection analysis tracks garbage collection frequency and pause times, which is crucial for optimizing memory usage and reducing application freezes. Leak detection identifies objects that should be garbage collected but remain in memory, consuming resources unnecessarily. Together, these techniques give you complete visibility into your application's memory behavior. Following best practices ensures accurate and useful profiling results. Always profile in production mode using release builds to get accurate performance metrics, since debug builds include extra overhead that skews results. Use realistic data by testing with production-like datasets and workloads, as performance characteristics often differ significantly between small test data and real-world scenarios. Run multiple times and average results from multiple profiling sessions for consistency, since individual runs can be affected by system variations. Finally, focus on hotspots by optimizing code that consumes the most resources first, following the principle that optimizing the biggest bottlenecks gives you the greatest performance improvements. Remember, premature optimization is the root of all evil, so always profile before optimizing.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.